in science. Today we're going to do a really simple science experiment called paper chromatography. I'm going to show you what you'll need to do it, the science behind it, we'll do the experiment, and then we'll analyze our results. I hope you're ready. Let's get started. All right, so paper chromatography. Let's start by seeing the things that we're going to need in order to do this experiment. Now you should be able to find all of these in either your craft supply space or your kitchen. All right, so let's look at our list. So the first thing that you're going to need is some kitchen towel or some paper towel. And it's best if this is white. You can also use coffee filters. In fact, coffee filters are a little bit more like what we'd actually use in a science lab. You also then need to take them and cut them into little strips like I've done here. Okay, so that's the first thing we'll need. And you really just need 1 or 2 pieces to get you started. The next thing you'll need is a transparent glass or cup like this one I have here. And you'll want to put a couple centimeters of water into it in the bottom. So that's the second thing that you're going to need. You will also need some markers or fine tips. And if you have a Sharpie, a black Sharpie would be really great for comparing how the fine tips work compared to a Sharpie. Now, in terms of what you do, you want to choose several colors. You'll notice I've got a yellow, a brown, a red, and a black. I find dark colors are going to be really interesting for separating, but light colors will tell us something interesting as well. So either one of those. You'll also need a pencil, and I have a mechanical pencil here, a ruler, and I've got a ruler here. And then last, hopefully you've got something easy to hand. A bit of alcohol or hand sanitizer will also help us with one of the things that we're going to do. All right, so let's see how all of this is going to work. Now, before we do the experiment, let's talk a little bit about the science behind it. So this is all about mixtures, and what we see is that the inks in our markers or fine tips are actually a mixture of different colors. Mixtures are things that are not combined chemically, so it makes them easier to separate by physical means, and paper chromatography is one of these physical means. And we're going to be creating a solution when we dissolve them into water. So a solution often uses water as a solvent, but not always. And a solution allows things to dissolve into it, in this case, our inks. So the solute will be our ink, which is what's being dissolved, and the water will be our solvent, which is what is doing the dissolving. And this is we're going to see whether or not our inks are soluble in our solvent. And that's why we're going to try and use the Sharpie as well, because I think what we'll find is our Sharpie is insoluble and your fine tips or markers should be soluble in the water. So soluble means it can dissolve, insoluble means it can't. We're also going to be using a pencil, and pencil is insoluble in water in our solvents, which is why we use it. And then we're also going to see which of our marker colors are mixtures versus which ones aren't. So I hope you're ready. Let's walk through how to do our experiment. All right, so let's get started. So I'm going to take a piece of my paper towel, and I'm going to take my pencil, and I'm going to also take my ruler, and I'm going to draw a line from about 2 centimeters from the bottom of my piece of paper towel, 2 to 3 centimeters from the bottom. I think I'll actually move to 3 centimeters from the bottom. So I'm just going to take my pencil and I'm going to draw the line across the bottom. Now there's a reason why I'm using pencil, and if you remember, we said pencil is insoluble in our solvent, in waters, which is why I'm going to do that. The next thing I'm going to do is take my colors that I've decided I'm going to use. I'm going to choose my colors, and I'm going to make a dot. So I think I'm going to use black, and I'm going to put a dot for my black on here. And I'll show you how that looks. So I've just put a little tiny dot of the color there. Next, I'm going to, let's say yellow. I'm going to take my yellow and do a dot. And think I'll also do a brown. And then lastly, I'm going to take my black Sharpie. So I'm going to end up with 4 different colors here. So I'll do black Sharpie last. Okay, and so now I've got 4 dots of ink onto my little strip of paper towel. I'm now going to take my bit of water, and I'm going to grab my pencil again, and I'm going to wrap my paper towel around my pencil. And as I wrap this around my pencil, what I want when I put this into the water is for the tip of this paper towel to touch the water, but I don't want the dots to get in the water. If the dots get in the water, I'm going to have to start over again. So I'm going to just pop this in, and I'm going to roll it a little bit more. I want to roll it so I can sit my pencil on top and it will hold it. All right, and there we go. So you can see the bottom of my paper towel is in the water, and the water is being pulled up through the paper towel, and now it's separating out the inks. So I'm going to let this sit for a few minutes, and then I'm going to come back and we're going to see what our results are. All right, I'll see you in a couple of minutes. All right, so here we are a few minutes later, and you'll notice I've done a couple of things. I took my pencil and my ruler, and I have drawn a line where the water stopped once it had moved through my paper. And now let's look at what's happened to our different colors. So the black has separated, and I definitely see some blue here. My yellow doesn't look like it's separated into other colors. Maybe there's two very similar yellow colors. If it hasn't separated out, what that tells me is the yellow isn't a mixture. It's a pure substance. It's just made of one color. So you might find that some of yours might not have separated, but they did move, and that's because they're soluble, but they're pure substances. And then the other thing I see here is that my brown has definitely separated into an orangey and a yellow color as well. So that one's definitely a mixture. And finally, you can see that the black dot there, the Sharpie dot, hasn't done anything. And that tells me Sharpie is insoluble in water. Now, I was expecting that, and you probably were too, because if you've ever gotten Sharpie on your clothes, it doesn't come out very easily. And that's because Sharpie is what we call an alcohol-based ink. It's soluble in alcohol. These other ones are water-soluble, as we've seen. So this goes to show that sometimes it doesn't mean we can't get something to move. We just need to change our solvent. So what I'm going to do now, I'm just going to take another bit of my paper towel, and I'm going to draw another dot on it. And I'm not going to dunk this into alcohol, but what I'm going to do is take a little bit of a colorless hand sanitizer that's ethanol based, and this is 70% alcohol. I'm just going to put a dot on top. Now this is quite gloopy because it's hand sanitizer. If you had isopropyl alcohol or rubbing alcohol at home, you could try that. It would work as well. You could also use a high spirit drinking alcohol. It would have to be high proof, like a spirit high proof drinking alcohol. That would work, but perhaps you wouldn't want to use that. And you can see that starting to separate out and dissolve my Sharpie. And now there's different types of alcohol too. So remember I said this one's ethanol, which is similar to drinking alcohols. Isopropyl alcohol or 2-propanol, that's a different form of alcohol, has a different structure chemically. So you could try different types of alcohols as well to see if it separates out. Now, one thing about alcohol is it's quite flammable, so you have to be more careful when you're using something like this as your solvent compared to using water, which obviously is not flammable. All right, so with paper chromatography, we have several different phases. We have the stationary phase, which in this case is the paper towel. Often when we don't use paper chromatography because it's not very economical. You would need a new piece of paper every time, especially for using filter paper, which is more expensive than paper towel. So we use something called thin layer chromatography, which is using something like glass with a soluble substance, a solvent that's on top of it, a coating on top of it, and it works very similarly. We get very similar results, but we can reuse the glass and reuse the solvent if we do it that way. And then we have the mobile phase, which in this case was our water moving through the paper in order to pull things and separate them out. And then this thing here that I have now, this is my chromatogram. So this little piece of paper towel with my results is my chromatogram. And finally, I can use this to calculate an RF value. The RF value stands for retention factor, and it's a ratio between the distance one of the colors moves compared to how far the solvent itself moves. So what I would do is take, for instance, let's say this orange, I'd measure up to the top of the orange, and then I'd measure up to the top of my pencil line in order to find out what the value would be for the RF value. So what this can tell us, what this can do is, if I know how far a specific color might move through my paper, I might be able to identify that specific color just by looking at how far it's moved through my paper. And so this is something that scientists can use. They can use tabulated values in order to work out what substances are in different things. So it'd be really fun if you wanted to calculate your RF values, if you're able to do that, calculate your RF values for the different colors that you have in the different inks that you use. So the last thing is how we use chromatography. So chromatography is used for lots of different things, and it's a really, really important analytical technique. So we can do something that real scientists do in their labs here at home very simply, or we could use some really involved equipment to do it in a laboratory. And so some of the things this is used for is water quality analysis to see what types of substances are in water. We can use it for forensics, so to match up things maybe found at a crime scene in order to see, maybe for instance, like a lipstick color, can you work out what type of lipstick someone was wearing by using different forms of chromatography. And then we can also use it to separate out mixtures and then take it another step in order to identify what's in the mixture in terms of its molecular compounds. So we could use something like infrared spectrometry in order to then work out what actually was made up in those, or mass spectrometry in order to figure out what molecules were in our substances. Now, as I mentioned, there's several different types of chromatography. So this is paper chromatography. There's high performance liquid chromatography. There's thin layer chromatography. There's gas chromatography. And these are all different types of things that you might learn about if you ever do more chemistry as you move through your educational career or as you learn more about chemistry. So listen up and hear about any time you hear the word chromatography and how it's being used, and see what you can learn from it. Well, I hope you enjoyed that little paper chromatography experiment. I hope it's something you can either incorporate into your classroom, or if you're working with your kids at home, it's something you can do with them. Or if you are a student watching that, it's something that has made a little bit more sense to you, and see how we do it and how we use the different things with it. So I hope you enjoyed this, and we can't wait to see you back here next time on Mrs. Wilson Science. Thank you.